from the Penn Libraries.
Thank you, Pratik, for presenting our online workshop on MATLAB for integration. Please go ahead and get us started.
Sure. Hi, everyone. Today we'll be learning how to do calculus with MATLAB. So initially we'll start off with few basic commands of MATLAB. So what we'll do is hopefully everyone's able to see my screen, and I'm typing my commands on the command window. CLC clears the screen. So let's just say if you have some equations of this sort, CLC just clears that. Other than that, you equate values to variables with equations like this. For example, if you type x equal to 5, x gets the value 5, and if you could see on the workspace, you get these values. In case if you want to clear that, you type clear, and the values on the workspace, it's clear. That's about the basic equations in MATLAB. Now let's see how to solve equations. So the purpose of today's workshop is to learn how to solve different types of equations, basic quadratic system of equations. Then we'll see how to solve derivatives of exponential trigonometric functions. And finally, we'll see how to solve indefinite and definite integrals. Let's just start off with simple equations. Before that, I type CLC to clear my command window. So all the commands that I'll be typing out today will be on command window. The commands that I type here can be put in the editor window and can be run as code. So let's just say if you want to solve a basic equation like x minus 10 equal to 0. So what you do is solve, and within single quotes you type x minus 10. So by default, MATLAB assumes that when you type x minus 10, the right hand side is 0. So once you do that, it shows the answer as 10. Uh, right now, since we've not equated that to any variable, it's the default variable is answer, that is ANS, and it stores the value over there. In case if you want to store it in a variable, let's just say y. So what we do is y equal to solve, and within single quotes again x minus 10. So let's just try it with a different value right now. So the right hand side is 2 right now. Answer should be 12. So yeah, y gets the value of 12. So this is how you solve basic equations. If you have any questions, you could start, or I can move on to the next set of equations, that is the quadratic equations. Before I do that, I clear my screen. So let's just say we want to solve an quadratic equation, say x squared minus 7x plus 12. So to do that, it's this same command that we used. So instead of putting the linear equation, we put in our quadratic equation right now. So you represent x squared in this form. Then you type 7x like this, and plus 12 equal to 0. So what happens is that it solves the value, and S will contain the answer. So once you do that, S has 3 and 4. So this is how you solve quadratic equations. Let's just try it with another value. I mean, it need not be X all the time. You can change the variable, but make sure that all the unknown values have the same variable. So yeah, this is showing a complex number with the left hand side having the real value, and then the first part having the real value and the second part the imaginary.
So Pratik, can you explain for us which part of this is, tells you that you're looking at an imaginary number?
Sure. If we type display of s of 1, so this part, the left hand side, square root of 5 by 2. There's another way of representing this. So if we type pretty of s1, yeah, it shows you this way. So as we can see, square root of 5 by 2, which is towards your left hand, is the real value, and then 5 by 2 is the imaginary one. Moving
Okay.
on, yeah, moving on, we'll see how to solve a system of equations. Uh, Instead of typing this in the command window, let's just write it in the editor window and run it as a form of code. So in case if we have an equation like x plus y equal to 5, and uh, let's just start with 3 variables because you'll have to have a set of balanced equations, and I have an example which has it that way. So 2x plus y 3z equal to 1. So this is our first equation. We just type it in there, and the second equation is, so whenever you're typing a multiplicative term, you put a star in between the values. So 2 star x is 2x, and 6 into y is 6y. Right now I'm equating it to 3. So that's my second equation. And this is my third equation. So when you type solve of all this, s has 3 values. In case if you want to run this, go to the editor window at the top, and once you try to run it without saving the file, you get a pop-up telling that the save is not filed and you will have to save that. Let's just save it as system of equations. So once you do that, yeah, so what we get in the command window, the solution is that, so we have a 1 cross 1 symbolic value. In case if we want to display the symbolic value, what we'll have to do is type x dot x. So that will give us solutions. I'm changing the code in the editor window, and once I click on run, so right now we can see that, okay, let me run the file again. Yeah. So what the output in the command window says that we've run system of equations. That's the name of the file. Then since we've not closed the equation over here without a semicolon, so it prints out that x has 3 values, x, y, z, and all 3 of them are symbolic values. Then I've typed s dot x, s dot y, and s dot z. So these are the answers of the system of equations that is printed out over here. So now I put a semicolon. Let's see. Before that, I'll just clear the command window so that it doesn't get messy. So yeah, right now we can see that x, y, z has 3 by 10, 2 by 5, and 0. So that's about equations. Uh, in case,
Question, Pratik?
sure.
On the right side in the workplace, you
Mhm.
have S and Y. Is that somehow the same S? Like, will it get replaced when you
Yes.
run?
So the values that you type in the command window, every time you write another equation with the same variable, that is being replaced. And the y value right now that we have is probably from the previous equation. So once we type clear, if you can observe the workspace, that that is completely erased. So once I run it again, all we have is just s and answer. So S is a structure containing 3 symbolic values, and then answer is the one that has the last value. So that is about equations. Now let's just move on to differential equations. Let's open another tab in editor window. I'll try to write most of my code on the command window. It's just copy pasting the same code onto the editor window and clicking the run button. So MATLAB provides the diff command for computing symbolic derivatives. Before getting to symbolic derivatives, let's just see what is a symbol in MATLAB. So once you type a variable like x, and if you don't type any value, MATLAB shows you this error saying that it's an undefined function. So if we want to represent differential equations or any equations, we would have to type something known as syms. That's the symbolic command. So once you type syms, x is treated as a symbol and it need not contain any value. So with this in mind, let's just try to solve a differential equation 5x cubed plus 2 divided by x square. I'll write that now. So let's just equate it to a variable f. So 5 into, so to write powers, you put the tilde sign. So what this means is that 5 is multiplied by x cubed plus 2 is multiplied by x raised to minus 2, that is nothing but 2 divided by x square. So if you want to see a better way of representing that, MATLAB has a command known as pretty. If we type pretty of f, we get this particular thing. So it says 2 divided by x square plus 5 of x cubed. Now let's just try to differentiate this. As I said earlier, MATLAB has a command called diff, and let's just pass the function f. So once we do that and click on enter, we get this particular answer. So that's the differential value of a function. A good way to see that would be, let's just put it in the pretty function so that we get a better idea on what we're trying to do. Yeah, so 5x cubed plus 2 divided by x square, the differential of that is 15x squared minus 4 divided by x cubed. So this is how you solve differential equations. Moving on to derivatives of exponential, logarithmic, and trigonometric functions. Let's just try a bunch of values. Before I do that, if you've cleared the workspace, you should make sure that x has a symbolic value. Let's just type y1 equal to exponential of x. So this is nothing but e raised exponential of x. If you want to compute differential of that, all we do is differential of y1 and hit on run. Right now I'm writing my code on the editor window, and a pop-up tells you that the file hasn't been saved. So let's just save it as differential. Yes. So differential of exponential function is nothing but the same thing. So you get the same answer.
That's great. Pratik, our Winnie has joined us in the attendee. She's attending, so I don't know if you can see the attendee window the way you are.
I mean, I'm not able to access that.
Yeah,
So
so I just
that's
wrote
fine.
to her to ask if she's able to hear us.
Sure. So moving on, let's just see how to solve other equations. Since x is already a symbolic value, we can just start writing equations with that. Y2 is the function, and then it has a value x raised to x to the power 9. If you want to do a differential of that, do diff of y2. Putting semicolons right after y1 as well as differential of y1. That is to make sure that the output doesn't get printed on the command window. Right now our focus is on equation y2 and then the differential of that. So once we run that, before that I'll just clear the command window so that we know what is the new values that are being printed. So it shows that the differential function is being run and y2 is given this value, and then the differential of that is 9 into x raised to 8. So it's the same command that you use with different functions. So the basic idea is to use differential function, diff, that is. Let's just try a couple more and we'll move on to integral functions. So let's do an equation, say cos of x. We all know that the differential of cos of x is minus sine x. So right now I'm putting semicolons after y2. Yes, so y3 is equal to cos x and the differential of that is minus sine x. You can do complex functions as well. For example, let's say y4 is cos of x raised to 2x squared, that is, plus 2 into x plus 1. So cos has this value inside, and this is given to the variable y4. If you do a differential of y4, this is the value that you get. To see it in a better form, let's just put it in a pretty function. And yeah, that's the value that you get. So that's about differential equations. Moving on, let's just see indefinite integrals.
Go. Let's just see if Winnie has any questions for us.
Sure. Hi, Vinny. I'm not sure if you can hear me, but if you have any questions, you can either put it in the chat box or you can just ask the question if you have a microphone and it's connected.
Okay, I
Okay.
guess we can keep going.
Okay, I'll move on. Uh, so there are two types of integral equations that we'll be solving today. The first one's indefinite integrals, and the second one's definite integrals. So if the derivative of a function f of x is f dash of x, then we say that an indefinite integral of f dash of x with respect to x is f of x. So what I said was, I'll type it in the command window. If this is our function and f dash of x is the differential of that, then if we're trying to solve an integral of f dash of x with respect to x, we get f of x. So let's just try to solve an equation right now. Again, we'll put x as a symbolic variable, and we have a function known as int, that is int, and that is used to compute integration values in MATLAB. Before I do that, I'll write it in terms of a function. So let's just say y is 3 plus 5 into x minus 6. I'm just writing a random example, but x raised to 2. So in case if you have any questions or while writing your code on the editor window, you can always copy your code and put it in the command window and hit enter. If it's a valid value, you get the output in the next line itself. If that is not the case, for example, let's just say I forgot to put this star right to 6 after 6, that is, and if you click on enter, it tells you that there's an unbalanced equation and the red bar indicates where you made a mistake. So it's always a good practice to write your code on the command window line by line and then just compile and or put them together in the editor window. So right now that is my y. Let's just say z will have the integral value of that. If we type in int of y, that will compute the int. Since I have not put semicolons after the equations, that will be printed on the command window. I forgot to save this, so let's just save it as integral. Yeah, so what happens is that y is given this value, and then z computes the integration of y and then puts it this way. To see it in a better form, let's just put it in a pretty function, but let's just put both y and z in pretty functions. So it says that there are too many arguments in y is equal. So what's happening is that it is trying to compute the function as well as print it out. So we'll have to write it in the next line. Let's just write it as per a of y over here. Same thing with z. So the first line, before that, I'll just clear the command window. Yeah. So the first thing is our equation, that is minus 6x squared plus 5x plus 3. And then the second value that is printed, that is this, is the solution to that. So this is how you solve integral equations. I mean, your example could be complex. All you have to do is just change your function accordingly and put it in int function, and then it'll solve it for you. Moving on, finally we'll see how to how to solve definite integrals. So by definition, definite integral is basically the limit of a sum. We use definite integrals to find areas such as the area between a curve and the x-axis and the area between curves. Again, we use int command. Okay, but the difference over when solving definite integrals is that we'll also have to pass the limits over which we'll have to compute the equations. Let's just take a simple example right now. Let's just take the above example itself since it's already here. So in case if we want to solve it over a range, let's just say 1 to 2. So the curve, that is 3 plus 5x minus 6x squared. What we did was we tried to compute a definite indefinite value in the previous case. Right now we're trying to put in values y x between 1 to 2. Once we do that, to do that, again, as I said, you'll have to pass it in the form of arguments to the function int. So first you write your function, your starting limit, and then your ending limit. So once you click run, before that I'll just clear the command window. So yeah, this is the function, and when computed between 1 to 2, it gives you minus 7 by 2. Uh, so that is how you solve definite integrals. Finally, we'll just see a simple case wherein we'll just see the plot and then we compute the value. I'll edit the same editor. in the same editor window. Let's just say if we have a function, say x raised to 3 into sine x, the pretty of y just helps you print that. And before I compute the function, I'll so as you can see on your screen, the variables that it takes is the function. So that's y, and the limits between which you want to print. So I would want to print between -3 to 9 and close the function. And then the z calculates the integral of function y between -3 to 9. And finally, let's just display the area. Okay, so since we have it ready, now let's just try to run the file. Yeah, so as we can see over here, we get a plot of x raised to 3 into sine x. So that's the plot that we have. We got that using EZ plot. So this seems to return a complex value. Let's just try to do a simple one and see how the solutions usually are. So I change the function to x. Okay, let me change it to x cube, and which is multiplied by sine x. So what happened was that x was raised to 3 power sine x. It became a very complex curve, as we could see. So I'm just changing that to a simple curve right now. So yeah, uh, yes, here's the curve. So I'll go through the flow of the program. The first line makes x as a symbolic value. Then y is where we write our function, this the second line. And in the third line, we just print it out in a pretty form. And the fourth line, easy plus between, it's drawn between -3 to 9. And in the fifth line, I'm trying to compute the integral of function y between -3 to 9. And at the last sixth line, in the sixth line, I'm printing it out over here. So once you click on the program, it generates the graph, it prints your integral, and then it prints out the area. So that is how you do definite integrals in MATLAB. And that is all the demos that we had today. So if you have any questions, feel free to ask.
Pratik, can you quickly talk about how you would get the graph out of MATLAB? Like, can you make it into a
Sure.
PDF?
So once you get your graph, go to File, Save As, and you have many formats. So let's just say if you want to save it in the form of a PDF, you just click on PDF, save the file as plot, sample plot, and it asks you for the location to save it. And,
Great, thank you.
mhm.
So Winnie has a question. What does double LE of Z do? When you did the area display double of Z, what did that accomplish in the last line?
I see. So it's just if we don't type, let's see what happens if we don't type double. So double basically limits the answer being printed to for presentable way. If we type display of Z, it prints this thing, and okay. If we type it this way, so A will have that particular value. I see.
Does double
Oh,
determine that it comes as a decimal point?
yeah. I mean, when you type display of A, it's trying to put the limits onto the solved equation, and when you put it in the form of a double of that particular thing, it computes the entire thing and then it gives you the answer. So without putting double, what's happening is that it's trying to just plug in the values, our limits into the equation, but it's not solving it. So once you put it in this form, it solves the equation. So let's just do that as well. So yeah, once you do that, it
So
computes the entire thing and prints it out.
it's like double in computer science where you're figuring out how many digits it's storing.
Yeah.
Okay. Winnie, do you have any other questions for Pratik?
All right. So
Oh, great. So thank you, Winnie, for joining us. We are recording this session. We're going to be adding it to the MATLAB guide. If you look about halfway up the screen, there are two links under web links. The first one will take you to the library guide that Pratik has created, and the second one will take you to the MATLAB official website.